Alright, so today we've got our first viewer submission. Thank you, Simon. Simon's question is, surveys show that 25% of adults read a daily newspaper. If 4 people are selected at random, calculate the probability that A, all 4 of them read the newspaper, B, at least 1 person reads the newspaper, and C, 2 people read the newspaper, given that at least 1 person does. So I'm going to call capital X is the number of readers. And so we can say that X is distributed binomially with a value of N and P. In this case, N is 4 because they've surveyed 4 people, and P is a quarter or 0.25 because that's the chance that somebody does read the newspaper, okay, from the question. So it's all about how you define your random variable and how you define your corresponding probability of success. I could have used P is 0.75 or 3/4, but then I would have had to say that X is the number of non-readers. Alright, now that that's out of the way, let's go ahead and do this. We have probability that X equals X, I'll just write out the formula first, is NCX P to the X Q to the N minus X. And remember, Q is just 1 minus P. So you could just write 1 minus P in there if you prefer. Now, if we had no choice but to do this by hand, then NCX is N factorial over N minus X factorial times X factorial, where factorial just means you're multiplying it by all the numbers that come before it. So for example, 4 factorial is 4 times 3 times 2 times 1. Of course, if you've got access to a calculator for this question, you might as well use it. So for part A, we know that N is 4, our probability of success is 0.25. We want to know what happens when little x is 4, or how often all 4 people are going to read the newspaper. And we can just plug these straight into our formula. Remember, if P is 0.25, that means Q is 0.75. So for NCX, we're writing 4 factorial over N minus X factorial, 0 factorial, which is 1, and X factorial is also 4 factorial, times P to the X, 0.25 to the 4, times Q to the N minus X, or 0.75 to the power of 0. What you should notice is that this is going to cancel out to give 1, this is going to cancel out to give 1, so our answer is the probability that X is 4 is 0.25 to the 4, which is 0.015. Now for parts B and C, I'm going to quickly draw up a table. I've got X, and down here I've got probability that X equals X. X can be 0, 1, 2, 3, or 4. Okay, we already know the probability that it's 4. So the probability that at least 1 person reads the newspaper is going to include all of these options, which means that for part B, we can write the probability that X is greater than or equal to 1 is 1 minus the probability that X is 0. So we're doing 1 minus, and I'll save you the calculation, 0.237. So finally we have 0.763. So I'll fill that into the table. Now for part C, the probability that 2 people read the newspaper given that at least 1 person does. So we've got a conditional probability thing going on here. And the formula for conditional probability, the probability that A given B is the probability of A intersect B over the probability of B. So what does this A intersect B mean? Well, this up here is our A condition, and given that at least 1 person does, that is our B condition. And this is why I've drawn the table. We want to know, where does 2 people reading the newspaper intersect with at least 1 person reading the newspaper? And this line in purple represents at least 1 person reading the newspaper, and this dot that I'm drawing represents exactly 2 people reading the newspaper. So this box over here is where those probabilities overlap. So for part C, we can just kind of brute force this formula to say that we're doing the probability that x is 2 divided by the probability that x is greater than or equal to 1. And I'll save you the calculation. The probability that x is 2 is 0.264, and the probability that x is greater than or equal to 1, we worked that out in part B. It's 0.763, and this whole thing works out to 0.346. So thank you, Simon, for your question. I hope that helped.